Hey guys, today we are going to continue graphing polynomials, but we get to use our friend the calculator. And this is the one thing that you're going to have to know how to do with a calculator, and so after this lesson, you'll totally be prepared to do the calculator portion of the test that is next week. So, your essential question today is, how do I determine characteristics of polynomial graphs using a calculator? And before we start with our calculator, we're going to talk a little bit about some important pieces of a polynomial graph. So I just have this random one graphed. In fact, I went to Google Images and I found one that looked kind of decent. So this blue graph is my polynomial. And if you look at this graph and we tried to ask you for a maximum or a minimum, there is no real true maximum on this graph, because you see there's an arrow up here and an arrow down here, which means that these graphs are going up and up and up for forever. So if I was doing domain and range, it would just be infinity. Now, I can, however, talk about local extrema, because these points that are red right here are important aspects of the graph. And what we call those are the local extrema, or the relative max or the relative min. So that they are the max and min of that area. So basically, a local extrema is just the highest or lowest point in an area of the graph. So if I was asked to find a relative min or relative max, let's start with our maximums. These two guys, -3, 2, and 2 positive 1, those are going to be considered local or relative maximums, because they are a maximum point. However, they are not the maximum point of the graph. So those two are local or relative maximums, whereas these two guys down here are going to be local/relative minimum. Okay, so that's a pretty basic concept. You're just looking for where are those topmost points. It's not the topmost point of the graph, but it's topmost point of an area. And the other thing that's interesting about local extrema is I know something interesting about them, and that is that if you know the number of little turning points that you have, the max number of those extrema is going to be the degree of your polynomial minus 1. So, for example, if you had the polynomial 3x to the 5 minus 3x squared plus 2x plus some other stuff, whatever, I would look at this and I would know that the degree of this guy is 5, because that's the biggest exponent. And so I know that this guy has a maximum of 4 higher low points. So I would know that there would be only 4 of these types of guys. So this could theoretically be that graph, because it has a maximum of those 1, 2, 3, 4 relative extrema. Okay, so those are just some vocabulary words that we're looking at here. The other thing that you need to know is increasing and decreasing. And this is actually even more simple. When you're thinking about an increasing function, or part of the function that's increasing, basically that's going up. Anything that's going up or would have a positive slope. So if I look at this guy, he's increasing right here, he's going up right here, and he's going up right here. And we just write that as an interval. And so we're going to use that, I believe you call it interval notation. We're going to say that my graph was going up from -infinity to the x value of -3. Then it stopped going up and went some down, and then we started up again at -1 up to 2. And then finally the last part that it's increasing is going to be from 4 on to infinity. So these are all the points or parts of my graph that are just going up. They look like they are increasing. And then decreasing works the same way. You're thinking about if you had a negative slope. I can't find a color I haven't used. Okay, so if you're decreasing, it's like if you had a negative slope of your graph, even though I know they don't have slopes, they're curvy. So we would have this little area, which would be from -3 to -1. And then going down again, we would have 2 to 4. Okay, and if you notice, I did put parentheses around those points, because technically at those turning points your graph is not increasing or decreasing, so just use regular parentheses in the interval notation. Don't use the brackets. So let's look at some examples on our calculator, because you know not all of our graphs are going to look nice and pretty like this one. So we want to find out, how am I going to find those maxes and mins? Okay, so let's grab our calculator, and our first example is this long polynomial, and we want to find out a couple things. We want to know where the relative mins and maxes are. We want to know where it is increasing and then where the graph is decreasing. So we're going to go ahead and go into y equals and type this thing in. So one thing you have to be careful of, the new operating system is pretty awesome when you get to use exponents, but you have to make sure after you've typed in your exponent that you get out of your exponent before you start typing again. Otherwise you're going to have a really big exponent. Do you see that it's still stuck up there? So make sure you get out of your exponent before you continue typing. Okay, and then you graph. If you're not on your regular 10 by 10 window, just hit zoom 6 and that should fix it. And you are definitely going to have to look at this and maybe change your window, because I can see already that there's part of my graph that I can't see at all. So there's a couple options for that. You could zoom out. If I know that I'm just probably a couple away, I could go change my y's. I know I wasn't really very negative, so I'll make that a -1 and then maybe make my y's go up to 20 instead. And so now when I look at my graph, I can see all those highs and low points. So if you looked right here, we knew this was a degree 4 polynomial, and then I can see all 3 of my relative mins and maxes. Okay? And so in order to figure out where those mins and maxes are, I always kind of like sketch my graph over here. In order to figure out where those mins and maxes are, you go to your second trace menu. Your second trace menu is super nice. It has lots of stuff going on in it. Okay, so second trace, and then it depends on what you're looking for. You're either going to pick a min or a max. Let's start with this maximum. So I'm going to do number 4. Now this is the kind of weird spot. You're going to have to do this left bound, right bound thing. So my cursor is kind of on that maximum point right now. I'm going to go a little bit to the left of it and press enter. You're just telling your calculator, look between these 2 points. Okay, again, I'm on that part that I think is my maximum. I go a little bit to the right of it. I press enter, and then you go and you guess. And then this is going to be your maximum. So if you want to know your relative max, you can list out that point. So you can list out -0.31, let's just round to 3 decimals, and then 12.643. Okay, now if they ask you for the maximum value at that point, they may only ask you for the y value. I just tend to write the whole point out so I have that information for later in a second. Okay, same deal for the mins. All you have to do is do second trace and then number 3 instead of 4, and then you pick one and you run with it. So I'm on my bottom point, go to the left a little, go to the right a little, go guess it. You do not have to guess it if you don't want. And then so one of my mins is going to be at positive 1.569 if I round, and then 0.876. I already found the other one, so I'll just tell you what it is, and of course it was the prettiest one on here, and it was -2.4. Okay, so once I have my mins and maxes, it's really simple to figure out my increasing, decreasing. Looking at my graph, I want to know for the increasing, where is my graph going up? So it's going up on this interval and this interval. So that minimum had an x value of -2. And then it went until this point, which had an x value of -0.319. Then it stopped going up and it started going back up again at 1.569, and it kept going on forever up. Okay, same deal with the decreasing. You just go ahead and you pull those points. So I see that it was decreasing the entire time, so -infinity, and then it stopped when we got to this -2. You're just using the x values here. Then it started going down again from -0.319, and it stopped at, what was that, 1.569, struggling. So when you look at all your intervals, you should have every number accounted for. Okay, so that's how you would solve any of those types of problems. Now there's one other feature that you might want to find on your calculator, and those are the zeros. And my graph that I have up here doesn't have any zeros. It's not crossing the x-axis. So I'll just make a new one of this quadratic graph that I'm going to hope goes through the x-axis. So I just type that in. And remember, if you want to refix your window after you've changed it, zoom 6. Okay, so it looks like it's going through. If I zoom in, maybe that'll make it look nicer. Oh, look how pretty that is. Okay, so if you want to find zeros on a graph, there are 2 ways to do that. The first way is through the second trace menu. And if I go to second trace, and of course I pick the one that says 0, and you're going to do the same thing that you did for the minimum and maximum. So if you kind of go to that 0 that you care about, then you go a little bit to the left, press enter, and then go to a little bit of the right of that 0 and press enter, and then guess. Don't go to the right of all the zeros, because then it'll give you an error. So one of my zeros is at 1, 0. Okay, so that's the first way you can do it. So that was zoom or second trace and then number 2. The second option you have is if you go ahead and you type in y2 and you give y2 a number. And remember, we did this when we did trig functions when we were looking for specific values. If I go ahead and I type in y2 equals 0 and I let that graph, I'm going to be looking for the intersection of my parabola and that and that line. So second calc number 5 would be the intersection. Second, or trace, I guess. Number 5. Get close to that point, press enter, enter, enter. Of course, come on, come on. Of course, it's going to take forever to get there. Enter, enter, enter. And so my second 0 was at 2, 0. Alrighty, and the last thing that we can do with our calculator is we can actually fit a polynomial model to a set of data. So the first thing, you'll have some sort of data. This guy says, after the winter break, 3 students came to school sick with the flu. The following table shows the number of students infected with the flu depending on the number of days after the winter break. So the first thing they're going to ask us is to find a polynomial model of the data. So if you remember, or if you see this, you notice they don't say you need to find a cubic model or a quartic model or whatever. So we're going to have to look at what the data looks like and then pick a model from that. So in order to do that, you're going to go to your friendly button Stat and then Edit. You're going to put your X's in L1, and we're going to consider our X's to be the date or the time in days, and then these will be my Y's, the number of infected students, and I've already typed mine in to save us some time. And then we're going to look at the scatter plot, and sometimes this takes a couple extra steps here. The first thing you need to do is do second y equals to get to the stat plot and turn your plot on. Otherwise, you're not actually going to be able to see any dots. And so once it's on, if you go to the y equals screen, you're going to see that it's highlighted. And I'm actually going to clear out the equations that we were just using so that doesn't affect anything. And then the easiest thing to do when you're worried about your window, you can look and try to find your highest and lowest values, but there's a nice function on the zoom menu. I want to go look at it first before I pick it. Oh no, there it is. Zoom stat number 9. So if I do zoom stat, it's going to zoom my data to look nice, just like this one. Okay, so I have this scatter plot. Now there would be 2 options for this one. Okay, somehow I just replaced that thing with a graph. Okay, anyway, so that's what my scatter plot looks like. I might be able, it happened again. I might be able to fit a quadratic model onto this, but if you look at it, it's kind of a little bit more funky. So there's 2 different options here. We can go to stat and then calc, and then we can pick whatever model we want. You see there's linear, quadratic, cubic, quartic, and there's also a power, but we don't need to pick that one. So if I pick quadratic, it'll probably fit my model pretty well. So if I go in quadratic, I can store my regression equation, kind of copy paste that in there if I hit alpha and then trace and enter, and this is going to put that equation into y1. I'm going to go down to calculate, I get all this business, and then if I go look at graph, I can kind of see what that model looks like. And personally, that looks not very good. It's not hitting any of the points, and there's a couple that are doing some funky things. So if I go back to stat and calc, and instead pick quartic regression, because I know that it looks like it's an even function, but maybe it's a little bit different. So if I go in here, and then again I do alpha, trace, y1, calculate, there's my whole equation, but then I go look at this, and this one seems to fit a little bit better. So you can always check that. You can also look at the shape of your graph, and if you notice that it has extra, relative max and mins in it, it probably is a higher order function. So if I go back, and I bet you mine is going to clear out. Yep, I'm going to hit that one more time. Do number 7. Not going to worry about pasting it because I already have it pasted. And all you've got to do is copy this down for the coefficients. So this one would be y equals, my a value they say is 1.3 times 10 to the negative 4. So that's actually a really small number. So you can move that decimal 4 places to be 1, 2, 3, 1. And if you let that out, it probably wouldn't hurt your model at all. Minus 0.012 x to the cube. And these variables are just going down. So then I'd have plus 0.26 x squared minus 0.393 x, I'm apparently rounding to a bunch of different places, plus 2.95. Okay, and that would be your polynomial model. So then you can use that model in order to answer questions like this, to find the day at which the number of infected students will reach the maximum. I could look at my graph and then just do second trace, find the max, which is 4, go a little bit to the right or left of it, and then a little bit to the right of it, and you can see my calculator pasted in that whole function, and so it's taking up all the space at the top of my screen. And so that maximum happened at about 19.5 days, or at about 20 days, we reached the maximum number of infected people. We'll just go whole numbers because that's what they gave it to me. And then you can also go find that 0. Now I may have to change my window a little bit so I can actually see stuff in here. So if I go make my y min maybe a little bit bigger and go find that value. Let that graph. And of course you can always do the second, or y2 equals 0. And if you notice, I'm a little bit not far enough out as well. So maybe it would be like 36 or something like that. So a lot of this calculator work is a guess and check, where you have to kind of keep zooming in and out to see if you can find the pieces that you're interested in. So if I do second calc number 2, somehow get over to that 0, which may take a while. We'll have to see if my calculator will let me do it without freezing. Oh look, it's going and I'm not even clicking it anymore. That's cool. Okay, there's a 0, go to the left of it, go to the right of it, and then we find out that by the 33rd day, no one should be sick anymore. Okay? And that's all I've got for you today. Have a great weekend, I believe.